600 with a kilogram meters per minute. Those are the things that we control. Now, the response of the subject is going to be based upon the conditions under which we set the independent variables. Now, the next level of, I know we have another marker, so where is that one? Okay, so the first level was the intensity of the effort, right? Intensity. And if you've been following along in the class, the thing that it depends on then is going to be the VO2. The next thing that is the metabolic rate. So the next will be the VO2. Okay, based upon that, we'll have other responses to that. They will be heart rate and ventilation and all the other dependent support systems that we have in place. So we set intensity. Got to make sure that that is exactly the way it was. Was there any question? Who monitored the power output and the rate of which was done? Any question as to whether they were maintained as we had set them? You know, you set it at 1. Did it drift very far? Or was it stayed very steady?
I mean, at first when it was rocking back and forth.
At the beginning, there might have been a little bit. So maybe early on in this, on the earlier bouts, that we might see an effect there. But for the second bout, it seemed like everything went very well.
Yeah.
Now, as you know, the controlling variable inside the body will be the metabolic rate. So metabolic rate is going to tell us how we're going to do with the pulmonary system and how we're going to do with the cardiovascular system in adjusting to that metabolic rate. This determines this. Okay? So this is the independent variable. This is dependent on that. When I get inside the body, the metabolic rate is the independent variable to these conditions. Okay? These are the dependent responses. So what do we have for our results? It's easy to look at the heart rates at first. Heart rates. On average, we see that the value is going to be around 70 beats per minute. No surprise to that. Varied a little bit, 64, maybe up to 89 in some cases that I had seen that, but all what we would see is normal responses in heart. But once we do the exercise, we start to let the exercise factors, the exercise metabolic rate, really control what's happening with the heart rate. At low exercise intensity, there may be some fluctuations as we see these numbers. But clearly, as we get to higher and higher exercise intensities, not really much you're going to be able to do to offset that. Now, as you look at, you understood the VO2 response. We showed that in class. So, wow. So it's VO2 versus time. What do we expect? Starting out at a resting value, right? And it's going to come up. It's going to level off. This is our theory. Low intensity exercise. What is this value that it's approximating in steady state? John went to the Excel files that we had, and he actually had that value at 0.85. It's calculated based on your body size as well as the intensity of effort. So here's what I'm looking for, 0.85. VO2 coming up, transitional state to a steady state. How long is it going to take? Probably 3 to 4 minutes to get there. What intensities, what minutes do we have? A couple in here, and we want to see if this is steady state here. From there on, it should not change. That's the VO2. Okay, second level of exercise intensity, 1.45, so it starts at rest. Didn't we? Steady state. What's the steady rate value? 1.45. Based upon our estimates of VO2. Okay, that's what I'm projecting. What's going to happen with ventilation? One of the things we talked about in class is that the rate, this is where we look at pulmonary ventilation as it relates to VO2. My expectation is for every liter of oxygen that I use, I'm expecting 20 to 25 liters of air per liter of oxygen. That rate. Okay? To support aerobic metabolism, the amount of ventilation I normally have will be 25 to 30. That's that ratio. 25 to 1. So in order to calculate what I expect for ventilation, so this is VE or VI, is approximately equal to the VO2 multiplied by 20 to 25 liters of air. Okay, liters of oxygen will cancel out. What's our first number? 0.85. Anybody run a calculation for me? 20 times that is what, 16 plus?
Our first one is 17. And then 25 is 21.25.
21.
Okay, somewhere in that range. Now, are we approximating that? Maybe a little bit high over here. See where that number is? Pretty steady. Very close to that ratio. A little higher though here than there. But again, I don't want to make a distinction here, but this equation that I have here will be VE, expired air. Okay? We only measured inspired air. Remember I said one of the things that we're not able to do effectively here is to measure the actual volume. So this difference, especially with room conditions that we have, we're going to create. So it's a ballpark figure for us, really, right? So we're sort of there. What about the next level? 1.45.
Maybe 29 for the lower half.
36.25 for the.
Oh, you guys are
GFKT.
together.
Maybe approximating similar to what we had at the low level. A little higher over here than compared to the other one. So she's breathing maybe a little bit higher than this ratio. Normally when this ratio is this level, we say the individual is aerobic. When there's anaerobic, we expect that to be somewhere between 30 and 35 ratio. Okay, that's really going to change these numbers quite a bit, not where we are. She's not anaerobic. So she's running a little bit high relative to my guesses as to what her ventilation values are. So ventilation, what did it do? This is a little high, this is okay, this is a little high. I'm not sure why this is there. She had the same breathing rate, a little higher ventilation volume. That's okay. Now as I look at this one, it came up. You see, it kind of stayed it out, didn't it? Didn't really change. Don't worry about the adjustment period. When we talk about breathing rate in the lectures, you'll get to that. Very quick adjustment of breathing rates to the exercise that we're actually doing. But it kind of stabilizes out there, doesn't it? And don't you look at this one, not too much different than the one we had here. We'll explain why that is when we get to pulmonary ventilation. And that's what's going to come up in the other lectures. So the full explanation of this lab can't be attained until after we get through pulmonary function and exercise. So I'll have to wait on that. How about the tidal volume? See how the tidal volume? A little larger on the second level as opposed to the first level. That's okay. What we expect. Again, when we talk about pulmonary, we'll do that. Heart rate. What's our indication of heart rate? What does this tell us?
If she's
Well,
working at her
yeah,
target
what?
heart rate. If she's working at her target heart rate or.
Yeah, sort of that same principle as we had.
Close to VO2 max.
Yeah, see what we usually use is 70% of heart rate max approximates in an exercise intensity the lactate threshold,
Lactic threshold.
as we talked about today.
Yeah.
Okay? So 70% of, let's say, a heart rate of 200, we're going to need your age as well. That has to be on the board.
I'm 23.
Make sure you write that down. But let's say it's 20, so a nice round number. 70% of 200, or 220 minus your age, would be a heart rate of 140, which is really where she is, just at that point. Okay? This intensity is lower based on heart rate, isn't it? But metabolically, what am I doing? I'm looking at heart rate using some principles that we have in relationship to metabolism, and I'm connecting those two with looking at heart rate. This is an aerobic task because of the base of the heart rate. When you calculate the percentage of max heart rate, it's going to be much lower, and that would be aerobic in nature. This one is at the borderline of maybe being what we call the lactate threshold. But at lactate threshold, is that aerobic, or is that aerobic and anaerobic? Which of those two? It's aerobic, right? Lactate threshold is the upper limit of aerobic metabolism. So just on the basis of heart rate, we have an indication that she's probably at or below our lactate threshold. By design, this test was set up so that you could be aerobic in both of these levels, and I think we achieved that. But the only data right now that I'm looking at to do that is heart rate. Eventually we're going to get to looking at breathing rate, looking at pulmonary ventilation when we get to it, as to another supporting set of data to tell us whether or not we're in an aerobic or an anaerobic state. So we'll use heart rate to guide our status of aerobics and anaerobic relative to lactate. We'll also use the dynamics that we'll see in the ventilations as to what's going on with the status relative to the metabolic side as well. And we'll do that in our next class. So far, I think the data really look nice from the standpoint of what we see. I think everything is working out. It would have been nice to be able to look at this. See, this is an estimate that we used, right? And everything that we did from here would indicate, geez, it should have been in this range. What's maybe telling me as a person doing that in fact this VO2 estimate may be wrong. You know, how would I get into this range? How would I get into that range? What would be the VO2 that I would look at to get us into that range? Obviously, these values, both low intensity and high intensity, are outside of our range for pulmonary ventilation, right? So I'm thinking, maybe her metabolic rate is a little high on a bike. Maybe she's not that efficient. This is more like 1.2 liters in oxygen usage truly, if we measured it. Then that would put this values right in the range of what we had expected based on the pulmonary values. And then whatever inefficiency she has on the bike at the low intensity, and she adds that into the bike on the high intensity, I expect this one to be bumped up. And that would clear up this relationship again, wouldn't it? So what I'm looking at is a real set of data. If I'm looking at the data, I'm thinking, this one's probably low for her, based on the physiology response. I don't expect her to be that far out of the range of these values in an aerobic state. She is. And so I'm saying, we estimated this, it's estimated too low for you. Maybe there's less efficiency that we have, and maybe less efficiency at the high. She brings both of those inefficiencies to both tasks, and that would explain away all of our data sets as we have. Does that sort of make sense? Okay. Clearly, as you do your lab reports, I need you to understand at the basis of steady state. Okay. Again, the introduction, as you write up these lab reports, introduction talks about the nature of steady state. That's what our tasks are. We actually collected some data at rest going up to low and moderate intensities. And you have to try to make sense, as I've done it, what the results mean in the context of theory. So that's what the nature of that lab report will be, going through each one of those sections, including a couple of references that you can have it out of the textbook or whatever. That'd be good. All right, any questions on the nature of I think you have a really good set of data here. One of the things that if somebody ends up bringing in the textbook, I would have normally done in that test is to do what we call ratings of perceived exertion. See, it's one thing to get the physiological results on people. It's the next thing to always understand their perceptions, right? You're doing something with a person in physical therapy, what are you saying? Oh, you got to do this. Oh, that hurts. Oh, that's too difficult. That interaction, changes